So 5G is network capabilities that were defined actually in 2015 by the International Mobile Telecommunications, the IMT 2020 standard, and that's an ITU group that defines that. Although it's new from a deployment perspective, people have been thinking about this for a long time. It has a number of dimensions. The first is the services dimension. So there are three services defined for 5G in IMT 2020. There's on the top here is the enhanced mobile broadband. So this is the high throughput and capacity that most people, if you see advertisements on TV in the US, there's a couple of service providers advertising pretty heavily. And that's what you're seeing advertised, the EMBB. The next service is the massive machine type communications, the MMTC. That's a large number of devices at low cost and power. So that's really what's enabling IoT service. And the third is the ultra reliable low latency communications. And that's really aimed for like factory automation, remote medical devices, other capabilities that are probably some future services to be delivered. A second part of 5G is the spectrum. In the US, there's a big deal about this new frequency 2 spectrum block. This is the millimeter wave spectrum. It's a pretty broad spectrum. It has the potential to provide a lot of throughput and capacity. The downside of these frequency ranges, these higher frequency ranges, is they don't penetrate objects as well. Objects like buildings or foliage, trees, other things. There's a lot of technology going into delivering the 5G capability in both of these frequency ranges and at these kind of capacities and throughputs. And then the last dimension of the IMT 2020 specification is the specific technical performance. And I think this is kind of interesting in a couple of ways. First of all, you don't get all of the capabilities for every service. And that's kind of what this chart shows, where, for example, the higher throughput is part of the EMBB, the enhanced mobile broadband, but it doesn't matter for the massive machine communications, and it matters less for the high reliability communication. So when we're talking about higher throughput and peak data rates, I mean, what we're really talking about is the spec says up to 20 gigabit per second downlink and 10 gigabit per second uplink. This is 20 times greater than what 4G had. 4G was up to about 1 gigabit per second. And again, I mentioned phenomenal radio technology. There's a technology that's been around for a little bit in some areas known as MIMO, multiple input, multiple output, and another called beamforming that are being used to deliver this. And these are very sophisticated technologies that put a lot of algorithms and physics into the radio part of the network to enable it to be used. Part of the peak data rate is what is the real user experience that's expected. It is defined user experience in dense urban areas for 95% of the time, and it's 100 megabit per second down and 50 megabit per second up. So it's great that we could do 20 gigabit, but that's where the spec is in terms of high density areas, which is still pretty phenomenal, enabling some pretty good services. Another dimension of the technical performance is latency. 4G, just for comparison, was at about the spec down to 10 milliseconds latency. 5G, the enhanced mobile broadband, is down to 4 milliseconds, so it's about half the latency, and down to 1 millisecond latency for the ultra reliable low latency communication. So give you an idea of what the spec is aiming for. Another dimension of the specification is mobility. So this is this max speed that a handoffs between the radio nodes is achievable. And it's spec'd at 500 kilometers per hour compared to 350 kilometers per hour 4G. So this matters if you're on a high-speed train, if you want to provide machine services on those kinds of environments, and maybe even for some other services. Communication density is another area that's had significant enhancement over 4G. The 5G spec is up to 1 million devices per square kilometer versus 100,000 devices per square kilometer for 4G. So that's a order of magnitude improvement. I will tell you there is no technical system that grows an order of magnitude without massive changes in order to enable it. And along with all of that comes all the kinds of things that you worry about in software, like how do you keep track of all these things, all the PDUs and others that go along with it. There's an energy efficiency spec. It's designed to be 100 times more energy efficient than 4G. And there's a spectrum efficiency spec, and that's 1,000 times more efficient than 4G. So even though some of the services delivery may not give more throughput than in 5G than 4G, it'll enable more communications to more devices, more users because of these types of spectral efficiencies.